What's up, Math Mob? We're back at it again with another video. This is Unit 3, Lesson 8. Our topic is linear equations, and our focus question, how do equations of lines change with different y-intercepts? Okay, let's look at our warm-up. The diagram shows several lines. You can only see part of the lines, but they actually continue forever in both directions. So these lines actually keep going forever in both directions. All of them. Which lines are images of line F under a translation? So here is line F. And we know when lines translate, they just slide somewhere, right? They don't rotate, they don't reflect, they don't get bigger or smaller, they just move to a different spot. So if I trace line F, right, like that. Now what I can do is I could slide this around and see which lines match up. So I'm going to go to line G. I can't get that to match up with line G just by sliding it, so I'm going to go to line H. So it looks like line H matches up. Line J does not. And line I, look like line I matches up also. So we have two other lines that match up. We have line I. We have line H, and we have line F that all line up. Okay, number 2 says for each line that is a translation of line F, draw an arrow on the grid that shows the vertical translation distance. So if I pick a spot here on line F, I'm going to pick this spot here. And if I translate this up, I'm going to go 1, 2, 3, 4, 5, 6. So this is going up 6 spaces. If I take line F and I go up 1, 2, 3, 4, 5, 6, it lines up. And on the other line, line I, I'm going to translate down 1, 2 spaces. So I'm translating line F down, straight down, 1, 2. And it lines up. Okay, let's look at our first problems. It says Diego earns $10 per hour babysitting. Assume that he has no money saved before he starts babysitting and plans to save all of his earnings. So he doesn't start with anything, starting with $0. It says graph how much money Y. So here on the Y-axis, is the money he saved. He has after X hours of babysitting. So on the X-axis here are the hours. So we want to graph this. So he's starting at $0 right here. And after 1 hour, he would earn $10. So 1 hour would be $10. 2 hours would be 20. 3 hours would be 40. 4 hours would be 50, and so on. So if I made a line through those points, it would look like that. Now imagine that Diego started with $30 saved before he starts babysitting. On the same set of axes, draw how much money, Y, he would have after X hours of babysitting. So his pay per hour did not change. The only difference is that he is starting with $30. So we're going to go up here and we're going to start right at 0 hours. He's already starting at $30. And since his rate of pay didn't change, he's still making $10 an hour. After 1 hour, he would make $10. So it would go from 30 to 40. Then after 2 hours, he would make another $10. 3 hours would be another 10. 4 hours would be another 10. So now we have, if we draw the line, that's what it would look like. Compare the second line with the first line. How much more money does Diego have after 1 hour of babysitting? 2 hours, 5 hours, X hours. So after 1 hour of babysitting, if he had $30 in his bank account to start, after 1 hour he has $10 here. And on this one he has 40, so that's a difference. This right here is a difference of $30. After 2 hours, he'd have $20, but if he started with $30 in account, he had $50. So the difference between 20 and 50 is 30. The difference between 30 and 60 is 30. So it looks like it's always going to be this green line here where he started with $30 in account is always $30 more, right? So if it was X hours, it would be X plus 30. So whatever the hours would be, he would make $30 more. Write an equation for each line. All right. So for this line, we know he makes $10 per hour. So the amount of money he saved on the y-axis, the amount of money would be equal to $10 times however many hours he worked, right? $10 per hour. So if he worked 10 hours, he would make 10 times 10, which is $100. On the other line, where he started with $30, the amount of money he makes would still be $10 per hour, right? He still makes $10 per hour, but he had a little savings already of $30. So we have to add that $30 to 10 times however many hours he worked. So here's our two equations, y equals 10x plus 30, or y equals 10 times x. Okay, the next one says this graph shows two lines. Line A goes through the origin. So here's line A going through the origin. Line H is the image of line A under a translation. Okay, so it looks like it got translated down, right? This line here. This line here looks like it got translated down. How many spots will go? 1. I'm just picking starting at the origin. I'm just going to move this down. Whoops. 1, 2, 3, 4. So it looks like it went down 5. Went down 5 spaces. Got translated down 5. So here our y-intercept is 0. Here our y-intercept is -5. And if you remember from our last lesson, this equation here B is the y-intercept, right? That is our starting point. So we're looking for a starting point of -5. So we could say y is equal to mx plus a negative 5. Or when we add a negative, we could just say negative 5. Y equals mx minus 5. So let's look for this negative 5 in these equations. So here we have a negative 5. That's a plus 5. That would make it up here. So that's not it. Here is a negative 5. Here's a negative 5. Here's a negative 5. And that's not a negative 5, but it's subtracting the 1/4 times x. So that is actually a positive 5. So that's not it. So we have these possibilities A, C, D, and E. So the other thing we need to look at is the slope. What is the slope of these lines? What is the slope of line H? Well, if I pick 2 points, I'll just pick here and right here. So I can make my slope triangle. And I have a vertical change of 1. Right? From here to here is 1. And a horizontal change of 1, 2, 3, 4. Right? I'm going from 4 to 8. And that is a change of 4, so my slope would be 1/4, which is 1/4. So I'm looking for y is equal to 1/4 x, right? Because this part is our slope. So I'm going to replace m with 1/4 plus negative 5 or just minus 5. Now I want to find out which of the equations above match this one. Well, this one right away, right? Y equals 1/4 x minus 5. That one for sure, because it's exactly like this. But what if I switched these around? Can I switch these? Can I say 5 minus 1/4 x? I can't do that because of the commutative property. There's no commutative property for subtraction, so I can't just switch these around. But what I could do, since I wrote it like this earlier, y equals 1/4 x plus negative 5. Now that I have this addition, the commutative property says I can move things around, right? 2 plus 3 is equal to 3 plus 2. So I can switch these around. They both equal 5, just as an example of the commutative property. So I'm going to switch these around. I'm going to say y is equal to negative 5 plus 1/4 x. So I'm going to look for something that looks like this. Y is equal to negative 5 plus 1/4 x is equal to, oh yeah, so this one, all they did was change which side of the equal, they just move these around, right? It's the same thing as it's here, except this is on the other side of the equal sign. So E is definitely true. And here I have exactly what I wrote right here, right? Y is equal to negative 5 plus 1/4 x. Have that exactly. But what about this one? 1/4 x minus 5 equal y. Well, again, all we did was change what side of the equal sign our expressions are on. So we just said 1/4 x minus 5 is equal to y. And y is equal to 1/4 x minus 5. So this one is also true. Okay, so let's take some notes. What is a linear equation that goes to the origin? So if we wrote this equation here, just like we did in the first problem, it was y is equal to (10x), right? Because we started at 0, we didn't have to add anything onto it because we started at 0. But the blue one, we could say that y is equal to 10x plus 30. So we have two types of linear equations here. Equations that go through the origin, so we have equations that go through the origin that look like this. Y is equal to, I'm going to make that black. Y, there we go. Y is equal to mx, right? So y is equal to whatever the slope is, whatever the rate of change is, times x, however many hours in this case. And we also have an equation where it does not start at the origin, where we're adding something, right? So we could say this one, a linear equation that does not go through the origin, is y equals mx, right? Y is equal to mx, the rate of change, the slope times x, but we're adding some amount. In this case, we were adding $30 to what he started with. So here is our two equations. Goes to the origin. And that means it's proportional. And this one does not go through the origin. And that is non-proportional.